Our next property looks at when we have a product, AB, raised to a power. Well, let's think if that's to the power of 3. Remember what we have here, since we have parentheses, our base will be that product. Our base is that AB. Raised to the 3rd power means times itself, AB, 3 times. AB times AB. Which now, going back to one of our arithmetic properties, if we had 2 times 3, it's 6. But if we had 3 times 2, it's 6. This one's called, if you want to know its name, is the commutative property, allowing us to change the order, but over multiplication, we still get the same number. Well, that's what we're going to do here. If we have A times B times A times B times A times B, alphabetically, let's let all the A's go to the front, let's let all the B's go to the back, and what we have is A times A times A times B times B times B. But think fundamentally what this means is A times A times A is A cubed times B times B times B is B cubed. When we have a power of a product, we get to apply the exponent to each. In a way, it almost looks like we're distributing, and careful because it is actually a commutative property in the fundamental expansion. We don't normally want to expand this kind of thing. What we want to do, and the way that I like to word it is, we apply the exponent to every factor within the product. So, as we have, power of a product property. If I have a product, AB to the n power, it means A to the m times B to the m. An example where we're going to see this the most, we're going to see a monomial, 5x cubed. Remember the 5x, just like we talked about, that 5 is a coefficient, 5 times x, which, according to our property, apply the exponent to each of those, apply the exponent of 3 to the 5, apply the exponent of 3 to the x, 5 cubed times x cubed. But what is 5 cubed? 5 cubed means 5 times 5 times 5. 5 times 5 is 25. 5 quarters, 125 x cubed. This is the kind of thing we wouldn't, again, even normally show this step. I want to show it right now because the fundamental of what this power of a product property is, but what we're still doing is applying that 3 to everything, and we normally would just say we're going to have smaller numbers, and we'll get used to our powers as well. We'll see those quite frequently. Another one I want to look at is x cubed times y squared times z to the 5th power. Now again, this is a product. X cubed times y squared times z. Fundamentally, it's going to look like distributing, but remember what we're doing is applying that 5 to each of those. X cubed to the 5th times y squared to the 5th times z to the 5th. But remember what happens now is, and it's not just because of the parentheses, this is my power of a power. When I have one base with the 2 exponents, right, that exponent just outside that parentheses, this is when I multiply x to the 15th. And we'll commonly see a lot of these properties just kind of mixed together in the middle of a problem. We just got to know what operation, when do I add, when do I multiply, when does it look like I distribute it. Y squared times to the 5th power, multiply my exponents, y to the 10th. And even over here, remember that if you have no exponent, that really is z to the 1st power. Y squared meant y times y, 2 of them. Z would just be z to the 1st power. Remember, anything always has that exponent of 1. Still multiply my exponents, 1 times 5, z to the 5th. And again, it's sure going to look an awful lot. We wouldn't normally show this step. It's going to appear a lot like the distributive property, but it is power of a product.